Okay, I'm going to try to cover note cards 27, 28, 29, and 30 in one podcast. The first three will be a lot of talking through the note cards and explaining some different principles. And finally, when we get to note card 30, that is when we will put it all together and work some problems. So this is note card 27, and we're going to talk about roots and zeros. It says if f of x is a polynomial function, then a solution of f of x equals 0, that means when y is 0, is called a root or a zero of the polynomial. There can be real or imaginary roots. The highest exponent tells the maximum number of roots because are both real and imaginary. Here's an example. So we have this x cubed plus 2x squared minus 8. It's going to have 3 zeros or roots, or in other words, it's going to have 3 solutions when you solve for x. So if I were to actually try to solve this, I would get x equals 3 different solutions. A root or a zero that is a real number is called a real root and a real zero. Graphically, real roots or real zeros of the function are where the curve crosses or touches the x-axis. They're also called x-intercepts. So when this function actually crosses here, here, and here, crosses the x-axis, those are the real roots, the zeros, the solutions. Okay? So here we would have these solutions are x equals -4 right here, -2, and +3. So graphically, that's how you would do that. Algebraically, you would have to factor this polynomial and solve for x. Imaginary roots or zeros, you'll have I in the answer, cannot be found graphically. You should recall from Algebra 1 and Algebra 2, working with I. And I is equal to the square root of -1. And the reason it's imaginary is because you can't really take the square root of a negative number. But there are places and times when you actually have these solutions because the graph doesn't cross the x-axis. It says this is a cubic function. There are 3 zeros, -1, which is a real solution, and 2 imaginary solutions. I'm sorry, this isn't -1. It says, it's just a dash. We have 1 real solution and 2 imaginary solutions. The 1 real solution is right here. You can see it's at x equals 2. And we have 2 imaginary solutions, and we cannot tell what the imaginary roots are, but we know they exist because this is the graph of a cubic function. And since it's the graph of a cubic function, it has to have, if you have x to the third, it has 3 solutions. That power indicates, this power indicates how many solutions you will have. Just reading through the rest of the note card, it says real roots or zeros may be found by factoring and setting the factors equal to 0 and solving for x. We talked about that. Both real and imaginary roots or zeros of a quadratic polynomial, x squared, may be found by using the quadratic formula. And that's also something we talked about in Algebra 1 and Algebra 2, and we'll probably do a quick review of that coming up soon. But continuing on for now, also synthetic division, we haven't talked about that yet. This is going to be something we talk about real soon. And number 8 says if we have this polynomial here, it says it has at most 4 zeros and turns at most 3 times. And we'll talk about the turning and such and so forth later as well. Right now, I just want to factor on zeros and roots. And you have as many solutions or zeros or roots, and those are all synonymous terms, as the highest power in the polynomial says you have. Note card 28 talks about end behavior. It says use the following chart to determine the sign, positive or negative, of a polynomial function. And so we have this chart here, and this is a very handy chart, and you're going to need this when you're graphing these functions by hand. If the highest power of the exponent is odd, then it says the curve from the left, it's going to rise from the left, and so if the highest power is odd and the curve rises from the left, then the function is positive. If the highest power is odd and the curve falls from the left, then the function is negative. If the highest power is even and the curve rises from the left, then it's negative. And if the highest power is even and the curve falls from the left, then it's positive. So using this, looking at these four graphs that I have down here, using this chart, let's see if we can determine if the graph is positive or negative. Here, you should see that this is an x cubed function, and it rises from the left, so it's odd. And if it rises from the left, then this is positive. This function would be positive. Here again, you should see that this is an x cubed function because it has that basic shape of the cubic parent function, and it has 1, 2, 3 solutions, 3 real solutions that you can see. And it falls from the left, and so if it's odd and it falls from the left, then this would be negative. Here, you should see that it's a quartic function. Because of the shape of it, it almost looks like a W. That means it's x to the 4th. That means it's even, and it rises from the left, so this would be negative. And this one is also a quartic function, has that W shape, and it falls, it's even, and it falls from the left, so it's positive. And these things are going to come into play when you're actually given an equation and you try to graph in just a second. And we'll talk about these things a little bit. And this right here was just kind of what I was explaining to you when I wrote it down, these little things here. When we get down to this point right here, regular pre-cal does not need to worry about this. Pre-AP, pre-cal, I'll discuss this with you in class. This note card number 29, it's talking about squared factors and cubed factors. This is a little hard to see. Let's see if I can make it a little bigger. It says if a polynomial has a squared factor such as x plus or minus some number and it's all squared, it says then x equals c, when you solve for c, is a double root or 0. And the curve touches the x-axis and changes direction at x equals c. It looks like the curve bounces off the x-axis at that point. So if we look at this one right here, you should be able to tell right away that it has that basic cubic function look to it. It looks like the y equals x cubed. But here's the actual equation. We have y equals x minus 1 in parentheses and then x minus 3 parentheses squared. This is a cubic function. It has 3 x's in it. If I FOIL this out, you would get an x squared term. And here I have one x term, which gives me 3 x's. But right here, where the curve just goes through the x-axis, this is a single root right here. But right here where it touches the x-axis and then bounces off, this is a double root. Which means that my solutions here are x equals 1 and x equals 3, but this counts actually twice because it's a double root. You have the x cubed function, which means we have 3 solutions, and so we have 1, and then this one where it bounces counts twice. In this next example, we have a quartic function, x to the 4th. I have one x term here. I have 2x terms here because of the square. So 1, 2, 3, and then 4. So this is an x to the 4th function. And right here we have a single root. Right here we have a single root. But here where the function is coming up, approaching from underneath the x-axis and then bounces off right here at x equals 3, this is again a double root. And the same with this one. This is a quintic function. I have a double root right here because I'm approaching the x-axis. It bounces off. Here I have a single, and then coming over here it bounces off again. I have another double root. So here I have a double root. At x equals 0. And I also have a double root at x equals 3. This next one says, if a polynomial has a cubed factor in it, such as maybe x plus or minus something all cubed, then when you solve for x, what c actually is, it's a triple root or 0, and the curve flattens out around the x-axis. So before we were talking about double roots and them bouncing off the x-axis. Here it's actually going to flatten out. Let's take a look. This first one, you see that it is y equals x minus 2 cubed. And you can also tell by the basic shape that it's a cubic. But as you look, it doesn't bounce off and it doesn't just go through the 2. It approaches the x-axis and it flattens out there, which means that x equals 2 is a triple root. So it actually counts 3 times. There's my 3 solutions, x equals 2. And here as well, we just have the negative version of what we just talked about. Negative, parenthesis, x minus 2, all cubed. And so it falls from the left, but it still flattens out at the 2, causing, again, a triple root at x equals 2. And my last example here, I have a quartic function, has that basic W-looking shape, and I can also tell it's quartic because I have 3 x's here, and I have 1 x here. And so it falls from the left, and so as it's falling from the left, look what happens at x equals 1. It flattens out, which gives me that triple root. And then my other root, or 0, or solution, is at x equals 3. And so since I have x to the 4th here, here's my 4 solutions. And that's how that works. And this is all about to come into play when I talk about this last note card. We'll be able to tie all of these 3 topics we just talked about together. Okay, so this is note card 30. And I have everything already worked out and everything graphed, but I'm going to add some things to it and really talk you through this. What you may be given on a quiz or a test or a homework assignment is a question that just tells you to, or a problem that tells you to, graph the function y equals negative x times x plus 3 all squared times x minus 4. And so you have to use all of the topics that we just talked about from note cards 27, 28, and 29 and put it all together to be able to come up with this graph. So how do we do that? Well, I can actually find my roots, my solutions, by knowing that, first of all, if I have a root or a 0 or an x-intercept here, here, and here, the y values of these three ordered pairs are 0. So I'm actually setting this function right here equal to 0 and solving for x. And when I do that, how I came up with x equals 0, x equals -3, and x equals 4 is that I'm actually setting each factor equal to 0 and solving for x. So if -x is equal to 0, then x is just 0. And that's how I get the 0. Here, I have x plus 3 all squared, which tells me since I have this square out here, this is a double root, going back to that other note card. This is a double root, and when I take x plus 3 and set it equal to 0, well, what I really have is x plus 3 times x plus 3 equals 0, because this is the same thing as x plus 3 squared. And when I set each one of those equal to 0, I get x equals -3. And it's a double root. It's a bounce. And that's going to come into play in a second when I graph it. And then finally, I have x minus 4 equals 0. And it should be obvious when I set x minus 4 equals 0 and solve for x, I get x equals 4. And so this is how I come up with my 1. This one counts as 2. And then this one is the 4th root or solution. So I know right away, before I even look at this graph, because this graph is not going to be given to you, I know right away, since I have 1, here's 2, and here's 1 solution, so I have a total of 4 solutions. That means I'm going to have a quartic function. It's x to the 4th, and it's going to have the basic shape of this w of the quartic. And depending on everything else that I analyze up here, it's going to tell me if it's going to rise from the left or fall from the left. It's going to tell me if it's a double root, do I bounce off the x-axis or do I go through the x-axis if it's a single root. If I have a triple root, I'll have to flatten out at the x-axis. So if I go back to this function that I'm given right here, I have a minus sign out here. And so if I go back to my end behavior note card and I look at that little t-chart, now what I'm about to do is I'm going to go back, but when I click off here, this stuff is going to disappear, but you already have it. But I want to go back really quick. So my sign on this problem was negative because in my equation it started off with a negative. And it's even because it has 4 solutions. So this tells me right here that from the left my curve rises. Let me say that again. When I actually had this problem written down, it was y equals -x. And then I had x minus 3 squared, and then x minus 4. That was a plus. So this minus sign right here is what I'm looking at. It's negative, so I'm looking at these two pieces right here. And so since it's negative and it's even, the highest exponent is even. I know that because I have 1, 2, 3, 4 solutions. So that's an x to the 4th function. 4 is even, so it's even and it's negative out front. So when I graph this, my curve is going to rise from the left. That's how I use this note card. So as I'm coming back, this is how I knew to start right here, somewhere down here, and rising from the left. And I'm going to, since I'm working from left to right, here are my 4 solutions. And again, this is a double. The first one is 3, the negative 3. This is where I need to approach first. And since this is a double root, that's why I'm rising and I bounce off. Doesn't matter how far I come down. It doesn't have to be perfect, but I bounce off because it's a double root. My next root is a 0, and it's a single solution, so I go right through it. And it doesn't matter how far I go up, just go right through it. And finally, my last solution is 4, and it's a single, so I go right through it. I draw my little arrow there. I've satisfied everything. I have the quartic. I have the W-looking shape. I bounced off at my double root. I went straight through my single roots. And this first example, that's how you use those note cards to be able to graph this function without a calculator. Now looking at this example, example 2, again I have a negative sign out here. Let's look to see how many roots we have. We have 1, 2, 3, 4, 5. I'm sorry, 2, 3, 4, 5. So I have a quintic function here because I have 1 root. Here's 3 of them. This is a triple root. And here is the 5th one. So I would go back to my note card on my end behavior. And it's negative and it's odd. So since there's a negative sign out front here and it's odd, my curve is going to fall from the left. So I look at this note card here to see where I'm actually starting my function. If I'm going to rise from the left or fall from the left. And on this one, I'm going to fall from the left. That's where I've got right here. I'm falling from the left. And then basically all I'm going to do is I'm going to look at what my roots are and see, and that's going to determine how I do the rest of the problem. When I set this equal to 0, I get x equals negative 1. I have a triple root at x equals 2 because I'm actually saying x minus 2 equals 0, and there's 3 of those. And when I solve for each one of those, I hope it's obvious that you see that I have x equals 2 and it's a triple root. And then when I set x minus 4 equal to 0 and solve for x, I get x equals 4. There's my final root. And again, I'm telling you that 2 is a triple root. And I've already went through the highest exponent is 5 and how it falls. And so here's how it would work. I know that it falls by looking at my end behavior note card. My first root from the left is negative 1. It's a single root, so I just go right through it, down underneath it. Again, it doesn't matter how far I fall. I just want to see you falling through here. My next root or solution is at x equals 2. And again, this is very important. This is a triple root, which means it flattens out. It's going to flatten out when I get to that solution mark, this x equals 2. So as I'm approaching x equals 2, I flatten out here, indicating that triple root, and then go back up. And then finally, my last root is 4, and I come back down. It's a single root, so it goes straight through, and I finish it off. I have that quintic shape. I have a single root here, goes right through. I have a single root here, it goes right through. I have a triple root here, and so it flattens out. And so that's how you use those note cards to be able to graph a polynomial given the form it's factored. You have to first have it in factored form so that you can see what the roots are. And if you can see what the roots or the solutions are, knowing if it's positive or negative, knowing that if it's got an odd power of function, this one was x to the 5th, so it was an odd power. Knowing that, you can tell if it rises from the left, if it falls from the left. And you can graph these. It shouldn't be that hard. I'm going to give you some practice so we can work on it.